we should be good to go. So I just need to get the Desmos link ready in a moment. So let's start with lines of symmetry then. So this is something that line of symmetry, I took for granted that students had a really good understanding of what that meant. But what is a line of symmetry? Well, it's an imaginary line. It's not one that you can always see. It's an imaginary line that passes through the center of a shape or an object that divides it in half, like equally. So on one half is equal or the exact same as the other, okay? And here's some examples. So you can see down at the bottom left, you've got a rectangle, and that has two lines of symmetry. It's got straight down the middle there and straight across there. Now, there are some students who suggest a line of symmetry goes diagonally, okay? But unfortunately, if you were to fold across that diagonal line, those two halves would not be identical. They would not cross perfectly, okay? So a rectangle only has two lines of symmetry and it does not include diagonals, okay? We've got the letter H. It's got straight down the middle there and then straight across the center. And it's the same for the first aid looking symbol there as well, down across, okay? I should have got more examples, but you're all going to be answering some questions on them, so I don't want to step on your toes. So lines of symmetry, you need to imagine that you can cut the shape in half and you'll be left with two identical halves, okay? That's what we are referring to with terms of symmetry, okay? Now, rotational symmetry, that's slightly different. Rotational symmetry is the ability or how many times you can rotate the shape and it look how it did at the start, okay, in one full rotation. So I'm talking 360 degrees. And now there's two different examples here. You've got regular shapes, so a rectangle, for example. If I come off of this page here, if I zoom in, hopefully you guys can see, if I rotate that rectangle, it will look the same twice. So I've started the rotation. Okay, doesn't look the same, no. Okay, there's once with a half rotation, and then we rotate it once again, back to the start twice. So the rectangle has got a rotational symmetry of 2, okay? The triangle here, this is an equilateral triangle. It's got equal sides and it's got equal angles. We can rotate that, okay, ready? So we start the rotation. It looks the same once, twice, and then back to the start 3 times. So it's got an order of rotational symmetry of 3, okay? So a rectangle has 2, rotational symmetry for an equilateral triangle is 3. Hey Liv, welcome, welcome. Don't worry about being late, it's not your fault, don't worry. I know we run these sessions at a time where students are just getting home from college. Yeah, well done for coming, I appreciate that. The next one we have, actually I'm going to ask you guys in the chat, what is this shape here on the right of my screen? What is that shape? Ooh, not quite a hexagon. A hexagon has 6 sides. This shape here has 5 sides, but I like the attempt. It's a pentagon, excellent, good, good, good. So this pentagon has 5 equal sides, okay? So how many times can we rotate? Just as a guess, guys, as a guess in the chat, how many times do you think we can rotate that shape and it will have or look the same? What do you think its order of rotational symmetry is? If you had to hazard a guess, if you had to put a guess on it, what would you go for? So if we could rotate that pentagon, how many times will it look similar to that in that exact position? Any suggestion is welcome. Don't worry if you're not too sure. The answer is 5. So if I rotate this shape 360 degrees, it will look similar 5 times. Once, twice, 3, 4, and then finally 5, back how it started. So there's a bit of a tease here, not a bit of a tease, that's a bit weird. There's a bit of a pattern. So it's how many pairs of equal sides it's got. So this one here, it's got 2 pairs of equal sides. So it's got 1 and then 2. So 2 pairs of equal sides, it's got 2 rotational symmetry. This has 3 sides that are equal, and it's got a rotational symmetry of 3, and the pentagon has 5, okay? So it's how many times you can rotate the shape and it looked like it did at the start. Irregular shapes, these are funky shapes. So shapes that we don't really have a name for. But basically, a good giveaway and a good clue is the number of points that it has. 1, 2, 3, 4. This shape will have an order, rotational symmetry of 4. You can rotate that shape 4 times and it'll look the same in one turn. This one here, once again, has got 1, 2, 3, 4 points. So we can rotate that shape and it'll have an order of rotational symmetry of 4. And then the final shape is this one. How many points does that shape have on the far right? How many points does that shape have on the far right, guys? What would the order of rotational symmetry be for that final shape? Ooh, not quite 6. Is it because you're counting these points here? It's my fault, my poor explanation. I'm on about like the arrowheads. That's what I should have said. The arrowheads and probably be a bit more specific there. It should just be 2 because it's pointing in 2 directions. So 1, 2. So it's got an order of rotational symmetry of 2. Okay. Now it sounds a bit silly, but this might be something that you just have to practice and have a play around with. Okay. The last thing I'm going to show you before I get you guys to practice some questions is this slide here. Okay, where we're talking about quadrilaterals. Now, I had a little quiz this week for my students where we talked about what is a quadrilateral. Okay, and if you're not my student, the best way for me to explain is by just writing it out at the top here. So it's a 4-sided shape. So any shape that you can think of that has 4 sides is known as a quadrilateral. So the quadrilateral is the group name for them. And here are 6 of them. Okay, you've got square, rectangle, parallelogram. But you'll notice here, trapezoid is what they say in the States, in America, but we're in the UK, so we call it a trapezium, a rhombus, and a kite. Okay. Now, what you can do, you can screenshot this, you can make a note on this. I will leave the slide on there so you can have a little sketch of it. But we know quadrilaterals are coming up, but we don't know what they might ask about them. It might ask you to, link the names of the shape to the correct picture. It might ask you to describe which quadrilateral has opposite sides that are equal and all angles 90 degrees, or 2 pairs of equal sides, all angles of 90. And you'd have to say, oh, that's a rectangle. So what we're going to do is just have a little chat about each one of these, give you hopefully time to make a note of them, and then we'll look at doing some questions that I've stumbled across online. So a square, all the sides are equal and all the angles inside are 90 degrees. Okay. A rectangle, it has 2 pairs of equal sides. Okay. The length and the width, and all the angles again inside are 90 degrees. My favorite one, parallelogram. Okay. The opposite sides are equal. Okay. So the top and the bottom are the same size, and the left and the right are the same, and they're parallel. What do I mean by the word parallel? This is an open question to the group. What do we reckon? What do I mean by the word parallel? It's a really fundamental part of the name of the shape, isn't it? Parallelogram. What are we thinking? Parallel. Lines that never meet. I'll agree. Parallel lines are lines that will never meet. They will never touch. So yeah, the top and the bottom of the parallelogram, those lines will never cross over, and neither will the left or right side. And then if you look at these angles, let me get my pen in a different color actually, because I'd rather it stand out a little bit more than the red lines. So let me just do that for you guys now. The angles opposite one another are the same. So this angle and that angle are exactly the same. So if that one is 100 degrees, then this one down here is also 100 degrees. Okay. Now, by that, we know that these angles are also the same. Okay. Let me just get my little pen ready. There we go. So they're the same. So this one here must be 80 degrees. And then this one down here is 80 degrees. So the angles opposite each other are the same. A trapezium, 2 sides are parallel. So often the top and bottom are parallel, and then the other ones will cross. So that's the difference. A trapezium only has one pair of parallel lines. A parallelogram has two. We have a rhombus, okay? That is like a diamond, but that's the official name, rhombus. All sides are equal, and the opposite sides are parallel. So once again, these lines will never meet, okay? And these lines will never meet on the other sides. And we get rid of the line in the middle. And then finally, we have a kite, which might take you back to your childhood. Maybe not. Not many people have kites these days. Anyway, the adjacent pairs of sides are equal. So this side here is the same as that side in terms of length, and then that is the same as that. If they were all the same size, they would all be a rhombus. So they're actually quite similar, these shapes, okay? They share stuff in common with each other, but some of them have differences, and those differences make them different shapes. So a square, a rectangle, parallelogram, trapezium, a rhombus, and a kite. They are our collection of quadrilaterals, okay? One last thing I'm going to say, angles inside of a quadrilateral always add up to 360 degrees. So that's something they all have in common. Quadrilateral, any four-sided shape, the angles inside will always add up to 360 degrees, okay? But we'll look at this in the future. If you want to screenshot that, make notes, hopefully I've left it enough time. I'll put this video onto YouTube as well, so you can come back to this to finish notes if necessary. Now, what sort of guy would I be if I did all the talking and didn't let you guys do any of the working out? So I've gone on to AQA. I have taken some of their previous past exam questions that look at lines of symmetry, that look at rotational symmetry, and then a little bit of quadrilateral stuff in there as well. So I'm going to send a link into the chat whereby I want you guys to practice looking at those questions. Give each and every one of those questions your best effort. Try and process the question as best as you can. Multiple choice questions, try and treat them as genuine questions. Get your own answer and then see if your answer matches with any of the selection of answers that are there. Yeah, the Desmos is up and running, so guys, feel free to log in, get stuck in. You're doing slides 1 to 3 to start you off. So lines of symmetry, rotational symmetry, and then some stuff on quadrilaterals as well. Okay, 5 questions, guys. Get stuck in, show me what you can do, and then we'll go through them together. Once you've finished and you're happy with your answers, pop up in the chat, say done, and that gives me a good indication of where we're at as a group. Okay, if you get stuck or you need any help, message me either in the chat or privately, and I'll do my best to support you. Okay. If we do have anyone who's not been on Desmos before, there's a link in the chat. If you click on that link, it will take you through to Desmos. It will ask you to sign in, but you can click on continue without signing in. You can enter your name and then you're good to go, and you'll be hit with the questions in front of you. Okay. Okay, guys, how are we doing with these questions? If you're unsure about any of them, that's absolutely fine. It is sometimes difficult online to give lots of good detail and specific answers. But what you can do is say, oh, I attended Sam's online session. We did this question, or can you speak to him about this? And then you can, because as a maths team, we're pretty tight. We're pretty vocal with each other. So anything you do struggle with, feel free to speak to your teacher about, speak to me about, find me in college. I'll do my best to help you with, okay? But when you're happy with your selection of answers, pop up in the chat, say, Sam, I've finished. And then I'll work through them with you and we'll get some answers, okay? Excellent, Abby, thank you. Abby as well. Oh, two Abby's, brilliant. I've just realised, because I don't normally teach at this time of day, my seating space, I have got a nice glow from the sun at this time. Okay, I'm going to give another minute and then we'll go through these questions, okay? Hopefully you guys are good. Hopefully this revision isn't something that's like completely foreign. Hopefully you guys are thinking, right, this is time to revise. The exam's in a couple of weeks. Time to get started. So well done. Okay, Jonathan, thank you for letting me know. I'm going to go through these now. I'm going to try and use my best teacher explanations for each one of these questions. So listen carefully, look as carefully as you can as well, and hopefully my explanations help your understanding. Okay. Well, thank you for letting me know. And if you're still struggling at the end, let me know, and I'll set you some work on Sentry, and I can speak to Katie, and she can help you in class as well. Okay. Right. Question number one. So guys, bring your attention back to the PowerPoint. I'm going to work through these questions now, so you can check your answers against mine, and hopefully we're all in some sort of agreement. Okay. So this is an exam question from the past. It says circle the letter that has a rotational symmetry of order 2. So what does that mean? Well, order of rotational symmetry of 2 means that you can rotate it twice and it will look, or you can rotate it 360 degrees and it will look the same twice. Now, this, let me get my red pen, it stands out a little bit better for you guys on the screen. Okay, so this equilateral triangle here, this triangle here, that'll have an order of rotational symmetry of 3. I can rotate that shape and it will look the same 3 times. Now, this circle, you can either argue it's got an infinite amount of order rotational or 1, but either way, it's definitely not 2, is it? Okay, it's a circle. Okay, a square. I'm going to ask you guys, this square here, how many times will it look the same when I rotate it 360 degrees? What do you reckon? Any other suggestions? We've got Abby saying 4. The clue is in the number of sides. So it's got 4 regular sides. So yeah, it does have a rotational symmetry of 4. Excellent. Now, that leaves by process of elimination Q, okay? But the reason why it is Q is you've got 2 pairs of equal sides and you can rotate it and it'll look the same once, finish the rotation, and then it'll look the same again at the finale. So Q is the shape there with 2, of an order of rotational symmetry of 2. Okay? Now, this is a funky shape. Let's call it the sun. What is the order of rotational symmetry for this shape? Now, I'm going to go on to Desmos and have a look at your answers here. What numbers have we got? Okay, I'll tell you what, most of you have put 8. Now, some of you put 0. Right, let me give you a clue. Because it's got 1, 2, 3, 4, 5, 6, 7, 8 points, we can rotate that shape 8 times and it would look the same each time, okay? So my number is 8. Although it's not a shape that has symmetry per se, it can still look the same, okay? So it does have a rotational symmetry of 8. So if in doubt, count the number of points or directions it's pointing, okay? Right, here are 5 flags. Which 3 flags have lines of symmetry? So which of these flags can I cut in half or in diagonals potentially to give symmetry? Well, there's definitely A. I could cut A in half down the middle and that would be 1 line of symmetry, okay? B. Right, there is no way I could cut that shape and allow it to have a similar, cut it in further down. So it's not going to be B. C, it isn't going to be. And then I've got D, down the middle works. And then E, through the center like that across. So A, D, and E. Which two flags do not have rotational symmetry? So which of these flags can I not rotate and then look the same? So let me just get rid of my lines of symmetry. So what are you guys thinking? If you had to put your hat on something, what would you say? So which one of those shapes can you rotate and it look the same? Have a look. Look at me, I'm rotating my head. Now, in an exam, what I would be doing is rotating the sheet, okay, making sure it makes sense, okay? So which two flags do not have rotational symmetry? So let's change the colour of my pen here a second. Come on, laptop, please survive. There we go. So C, right, C does not have any, because we can't rotate that shape at all and it look the same. Now, A, C, E. Now, E, if I rotate that, look at me, I'm imagining it, yeah, I'm imagining E, I'm rotating it. It will only look the same once, okay, when we do 360. B, however, I'm literally rotating my screen here. These shaded areas are a different size. They're a different size, so yeah, that won't look the same. So I'm going for B and C on that one, okay? It is tricky though, flags, because they're not traditional shapes, are they? And it's even more so when we've got these here. These are car badges by the looks of it, aren't they? So which two of the badges have exactly one line of symmetry? So I'm looking for two of them here. And I'm going to steal your answers off of Desmos. Lots of you have put A. Some of you have put C. Some of you have put D. So I definitely agree with A. Down the middle there, that is a line of symmetry. Okay, so A definitely has just one. B has a few lines of symmetry. It's got one there. It's got one there. And you could even argue the diagonals are lines of symmetry as well. This shape's got three, because you can do it through the points. Quite hard to draw lines of symmetry sometimes. But we're looking for one. Now, I think it's C. There, down the middle again. So I'm saying A and C. And it says here, which three badges have rotational symmetry? So which three badges can you rotate and they will look the same? So definitely B, definitely D, and definitely E. You can rotate those shapes and they will maintain that same starting position. So B, D, and E. And I'll write that down just so it's nice and clear. B, D, and E. Often tends to be the shapes we've not done yet, that we've not identified yet. Now, the last question, which I was really impressed by, to be honest, because most of you have got this spot on. If not, everyone on Desmos has got this right. What is the maximum possible order of rotational symmetry of a quadrilateral? Well, hopefully you guys are thinking of a square. That shape has four pairs of equal sides. That means that's our best quadrilateral to pick, because it's got four pairs of equal sides. That means it will look the same 4 times. No other quadrilateral will have more rotational symmetry than 4. It's limited, it's capped at 4, okay? Now, that is rotational symmetry, lines of symmetry, and a little bit of quadrilaterals. Covered it in about half an hour there. Hopefully it's something we can hold on to remember into the future. We're now going to look at circle terminology. Now, I'm trying to remember, it comes up on paper 1 and paper 2. So I think paper 1 is circle terminology, and then paper 2 is parts of a circle, something like that. So we need to know and be familiar with some of these words. Now, I'm going to write these on. I want you guys to look, listen. If you want to draw a circle out, that's absolutely fine. If you want to screenshot this, absolutely fine. But we need to be comfortable with these words. So here we have a bold line that is highlighted as part of the circumference. Now, that bold line there is an arc. It is a portion, a part of the circumference. Okay? We then have this line here. It goes from the center to the edge. That is our radius. The radius goes from the center to the edge. We now have a line that goes all the way through the circle, through the center, and then to the other end. So it goes from one edge to the other, but it goes through the center. That's known as our diameter. Now, the radius and the diameter share a special relationship. If you know one of them, you can calculate the other. So for example, well, actually, let me just say this as a statement. The radius is half the length of the diameter. So if I know the radius, I can double it and I'll get the diameter. And if I know the diameter, I can half it and then I'll have the radius. So those two are kind of like brothers, if that makes sense. They link together. So if you know one of them, you can use it to work out the length of the other. Hopefully we're familiar that the center of a circle is bang in the middle. Now this green section here that's been shaded, that is known as a sector. It's like a pizza slice. Now, the reason why I remember it as a sector and not a segment is because a sector has the letter C in it, okay? And the sector always involves the center of the circle, okay? So if it involves the center, it's a sector. My favorite part of a circle here, this line, it comes in, it touches it, and then it goes off. It's known as a tangent. I always remember that, a tangent. And then this black line all the way around the edge, that's known as a circumference. Now, hopefully some of you are saying this out loud behind the screens, that's fine. I would normally ask the chat and say, guys, what do you think it is? But as this is like a lecture style session, I'm going to do a lot of the talking, okay? We have two parts of a circle left. We have this line here, goes from the edge to this edge here, but it doesn't touch the center. So that's the difference between the diameter and a chord, okay? A chord goes from one side to the other, but it doesn't do the center. It doesn't go by the center, but the diameter does. And then we're left with a segment. Now, a good way to remember a segment, it kind of looks like a Terry's chocolate orange piece, and they're often called segments, okay? So yeah, we need to remember the difference between segment and sector, and then hopefully come up with other ways to remember other strategies to learn the words. If you learn those, you are guaranteeing yourself some marks in an exam, which is quite a nice position to be in. Now, I'm going to shut up again because I get bored of my own voice. I'm going to let you guys work through some circles questions. It's all about identifying parts of a circle and using your knowledge and understanding of parts of a circle to get some marks. Once again, I've selected nothing but past AQA exam questions, so we can see how they look, what we can expect going forward in the future. Now, they won't be the same as these, but they're going to be similar, aren't they? So I'll put a link back in the chat for Desmos. You guys know the drill. You can click on that link. It'll take you to where you need to be, and then you're good to go. Okay, I'll leave my slide as it is because you can refer back to it for support. That's revision at the end of the day. That's fine. And as you've done previously, pop up in the chat once you've done, and I'll go through these questions with you. Okay, good luck, guys. Enjoy the questions, and I'll see you on the other side. Hey folks, I've just seen for the final question, 4C, you've not actually got the ability to write an answer, have you? So I have written, or the exam question's there, but there's not an answer box. So feel free to send me an answer to me privately, or just have a think about that question. The one where it says, write down a difference between a diameter and any other chord. That's me trying to be a whiz on Desmos, missed an answer box. Not good. Okay, so try and arrive at some answers for those questions, and then in a minute, I'm going to go through them, okay? Now, I do apologise if I'm going at a quick speed. I'm just conscious that within an hour, and I want to cover things in like blocks, I need to go at a certain pace. So I do apologise if I'm going slightly too quick. Hi, Jonathan. So, Jonathan, on Desmos, so I don't know if you used Desmos before, you don't have to sign in. So if you click on continue without signing in, you can just enter your name and then you've got access to the questions. So you don't actually have to sign into Desmos. It's not something we get students to do because it gets a bit messy at that point. That's something we can do. I can get Katie to show you. So then next week, you're like, yep, straight ahead, straight in. Okay. Bring your attention back to the PowerPoint. This is for everyone. Bring your attention back to the PowerPoint. We're going to look at these questions now. I've snipped them from past papers. So hopefully you like the look of them because, you know, AQA aren't going to change the game that much. They're going to ask questions that look similar, very similar to this. Now, what you want is to be a student that gets this question right, and I hope lots of other students get it wrong, because then that means you're making ground on them. Okay, sounds a bit harsh, that does, but you kind of have to be a bit selfish with these exams. You got to think, right, I want these marks. I don't care about anyone else. This is what I want. So when it comes to this question here, it says O is the center of the circle. You've got line MN, you've got line OA, and then ST. So the line MN, that is from one edge of the circle to the other, but it doesn't go through the center. So it's therefore a chord. Okay, it's a chord. Now think of a guitar that has a set of chords. They don't go through the center of that. I don't have a guitar here with me, unfortunately, but it doesn't go through the center necessarily. You can go through, yeah, anyway. This line here goes from the center to the edge. I'm going to ask the chat, what is that line known as? From the center to the edge of the circle. I'm not going to do much work now. I'm going to get you guys to do it. Kate Nicholson, radius. Oh, it is the radius. Okay, the diameter is a line that would go all the way across. So the diameter would be all the way across. The radius is from the center to the edge. Okay, excellent, Josh, as well. Now the line ST right at the bottom down here touches the edge of the circle, then goes off. What are we saying for that one, guys? Touches the edge down here, and then it goes off. It is known as a tangent. Excellent. My favorite part of a circle, and I don't know why. I think it's because it's so random. But yeah, it's known as a tangent. So how many marks would you get for those? 1 mark for chord, another mark for radius, and another mark for tangent. 3 marks for learning your parts of a circle. Okay, quite generous that is, but that's how it is. On a circle, which of these is not a straight line? Right, well, sometimes it might help to draw a circle and then label it. So a radius is a straight line. A chord, goes from one edge to the other, straight line. Diameter goes all the way across. The circumference, well, that's the name for the perimeter of a circle, which is definitely curved. So yes, the circumference is a curved line. It says here, on a circle, which of these is always longer than the diameter? So no matter what, which of these is always longer? Now a chord, no, because chord can never be longer or can never always be longer. An arc, sometimes it can be longer, but you can sometimes have like a little arc. Okay, not an arc. A radius, definitely not. And we're left with, oh, once again, circumference. So the circumference goes all the way around the edge. So no matter what, that will always be longer than the diameter, because the diameter goes across, whereas the circumference is the entire edge or outside of a circle. Okay. Last little bit. The straight line from C to the circumference is called a radius. The shaded area, right? So it involves the center of the circle. So I know it's a sector. And then the last question, which you guys weren't able to actually give an answer to, my apologies, write down a difference between a diameter and any other chord. Well, hopefully I'm going to, well, actually in the chat, guys, what makes the diameter different to a chord? I'll give you guys the chance to type this. What makes the diameter different to a chord? There's one key difference I'm thinking of here. Well, not necessarily. Sometimes it can be longer. I think it is longer. I'll settle for that. I should have put up the mark scheme, shouldn't I? I'm trying to think. I think a diameter should always be longer. But yeah, so I'm going to take that longer, but I will double check that. That's something you made me think there. But I was looking for what Kate said here. The diameter goes through the center. Okay, so no matter what, let's draw a circle here. The diameter, it can't, oh no, that's a terrible diameter. A diameter always goes through the center. Okay, and a chord doesn't. There you go, there's that. And a chord could be over here. That could be a chord. But yeah, if it goes through the center, diameter. Okay. So diameter always goes through the center. And yeah, I think test me there longer. I'll find out. Okay. We're now going to look at vectors. Now, vectors, guys, these are basically just a set of instructions. Okay. Now, it tells you how to move a shape up, down, left, right, or yeah, up, down, left, or right. You've been told in your exams that you're going to have to do vector arithmetic. So that means add, subtract, times, divide, that sort of thing. That's what arithmetic is. So don't worry about moving shapes. We're here purely to do some maths with vectors. And you'll see the exam questions I've got are exactly the same. Addition, multiplication, subtraction in there. Okay, so these three examples hopefully will help you out. So what does it mean? A is 4, 7. B is 5 and then a 9. What is A plus B? So 4 and 7 plus 5, 9. Right, add across the top, add across the bottom. That's all we need to do. So 4 add 5 is 9. 7 add 9 is 16. Done. That's it. We don't have to make it complicated. If we're adding them, we add the top numbers together, we add the bottom numbers, happy days, okay? Now, I am going to just quickly check something, because not only do we want to kind of know, well, no, I want to know if it's what paper it's coming up on, okay? So I know it's coming up. So vector arithmetic, can you see here? Vector arithmetic down there, paper 3. So what does that mean? That means I can use a calculator. So makes your life even easier. So if you get some awkward numbers, you can use a calculator to support you in your answer, okay? Right, so let me go big screen again. Let's move on to the second example. Right, it says here, A equals minus 3, 4, B equals 5, 7. What is 2A plus B? So, 2A. What do I have to do to this? What do you reckon? A is minus 3, 4. What do you think I have to do to it before I do my addition? I'm asking you guys now. I should have said that actually. What do you guys think I should do? There's 2A. Times it by 2. Excellent. Yeah. So take minus 3 times it by 2, 4 times it by 2, and then that'll give me my new vector to work with. So minus 3 times 2 will give me minus 6. And then 4 times 2 is 8. And then we're going to add it to B. Remember, B stays the same. So that's going to be 5, 7. Remember, add across the top, add across the bottom. And because it's a calculator paper, use a calculator. Minus 6, add 5 is minus 1. So the top of my new vector will be minus 1. 8 add 7, 15. Thank you for those marks. That'll be worth 2 marks in an exam, and it will appear towards the end of a paper. So even if you've hit a few questions that you're stuck with, keep progressing through, because you may stumble across this and be like, I can do this. That's an extra 2 marks to your grade. Okay? That's my last example. So this one, it says 3A. 3A. So I need to times this by 3, and then that one by 3. So let's do that now. So I've got minus 1 times 3, which would give me minus 3. Minus 5 times 3 is minus, get rid of that weird, there we go. That's going to give me minus 15. That's my new vector. Now I've got 2b. So that means 2 times it by 2, doesn't it? So times by 2, times by 2. Well, 2 times 2, oops, is 4. And then 3 times 2 is 6. And what are we doing? We're subtracting. So I need to do minus 3 take away 4. Minus 3 take away 4 is minus 7. So the top number, minus 3 take away 4 is minus 7. And then minus 15 take away 6. That'll give me minus 21. Now, yes, they're negative numbers. Does it matter? No, I've got the right answer. Happy days. So you can turn that frown upside down, okay? So that's vectors. They look and sound quite difficult. It's kind of cool because if you can master them, you can say, yeah, I can do vectors. It sounds good. So make sure you're keeping an eye on these numbers. If it says 3a, times those numbers by 3. If it says 2b, times b by 2, etc., etc., etc. Okay? The best way for you guys to get and develop these skills is by just doing them, I believe. So I want you guys to get stuck in. So spend 10 minutes maybe on these. I'll spend 5 minutes reviewing them, and then we're done. Okay, so we've looked at a few different things this evening, but let's finish strong on vectors. Okay, so link into the chat for Desmos. Click on the link, click on continue without signing in, enter your name, and then work through those 5 questions, all of which. Now, one last thing I want to say, I don't think you could submit your answer as a vector. So just put down, for example, I would write my answer as minus 7 and minus 21, or minus 7, leave a space, minus 21. I'm happy with that as your answer line on Desmos, okay? Or put it as a fraction, so I'll get the gist of it. As long as the numbers look good, I trust in an exam, you put them in the right place. Any questions, give me a shout. If you want me to do another example, I'm happy to do so. But yeah, see what you can do on Desmos, guys. Hey Lucy, I've just seen your message with, how do you do this? I've just only logged back in, that's fine. Right, I'll do question 1 and explain what we're doing, okay? So Lucy, are you with me? Yes, excellent. Okay, so Lucy, what we need to do here is just look at what the question is asking. So we've got C, that vector is 4 and then a 9, and then D is 2 and then a -5. And it wants me to work out what is 4C plus 3D. So 4C, that wants me to times C by 4 first and foremost. I need to times those numbers by 4. Then that completes that part of the question. So what is 4 times 4? Well, that'll give me 16. And then 9 times 4 is 36. So 4C as a new vector would be 16 and then 36. Okay? So that's the first bit. Now, what do I have to do with D? I'm going to ask you here, what do I do with D? Perfect. Excellent, Lucy. Yeah, times them by 3 because it's 3D. So we're going to times it by 3, top and bottom. So 2 times 3 is 6. Excellent. And then -5 times 3 would be -15. Now you'll see here we're adding them. That's crucial. Get the symbol correct in the middle. We're adding them. So what do? Well, we add the top 2 values. So 16 add 6 is 22. And then we add the bottom. And this is going to be on a calculator paper, so don't even stress with the negative numbers. Just use your calculator. 36, add -15, 21. My final answer would be 22, 21, and that would be worth 2 marks. Does that make a little bit of sense? Excellent. You're either a very good student or I'm a very good teacher. Maybe it's both. But yeah, have a look at the other questions. In 2 minutes, I'm going to go through some of them. Just ignore me if you want. That's absolutely fine. A lot of my students do anyway. It's okay. Okay, I'm just going to have a look where we are with the questions. Okay, now I'm going to give you 5 more minutes. I want you guys to take your time with these, so a bit longer. I know the session was scheduled for 7 o'clock, but hey, we can run over, it's fine. If you've got places to go, people to see, that's fine. If you need to dip out, that's okay. But if you want to stick around to see the answers, that's okay. If you're in a position where you're happy, or no, not where you're happy with your answers. If you're in a position where you've got answers for each one, double check them, make sure you're happy with them at that point. Just do the calculations again. Use your calculator again. Now, if you've done them in your head, then use the calculator. I'm only saying that because I know this would appear on a calculator paper. So to guarantee yourself marks, use a calculator to do some of the sums. You'd be silly not to. Okay, my Wednesday revision team. That's our new name I've made as a team. We're going to look at these answers. Okay, so question one I did do. So I'm going to, instead of going back through that, because we've got 4 examples, I think there's enough examples there for me to talk through instead of going back through question one again. So question one was 22 over 21. You can see someone working out there. So C times those values by 4, top and bottom, and then D times those values by 3 to the top and bottom, and then I added them together. So 16 add 6 gave me 22, and then 36 add minus 15 gives me 21. Okay. Next one, we have A minus 3B. Now, it's a bit blurry, this, but hopefully you guys can see. But A stays the same, so that's going to stay at minus 3, 2. And then we're going to minus 3B. So 3B, I have to times B, or the values in B, by 3, top and bottom. So 1 times 3 will be 3, and then minus 5 times 3 is minus 15. Okay, now crucial, you notice here I've got a subtract symbol. So once again, I'm just going to be lazy more than anything. Minus 3, minus 3, minus 3 is minus 6. That's going to be the top number. And the bottom number, 2 minus 15 will give me 17, because a minus and a minus besides each other gives me a positive, so it gives me 17. So minus 6, 17. Hats off to anyone who's got that. If you use the calculator like me, oh, look at you guys are good. I can see a lot of minus 6s. I can see a few 17s. Now, this is a 2-mark question. 1 mark for minus 6, a 2nd mark for 17. So even if you're not getting both of them, if you're getting one of them, it's not a bad position to be in. But like, guys, look, I teach maths 5 days a week. Okay, for the last 5 years, I'm still using a calculator because I want to guarantee the correct answer. And like I said, you're allowed to. So You'd be silly not to. Here, work out 3a plus b. So b stays the same, okay, but 3a, we have to times a by 3. So 2 times 3 and then 7 times 3. Well, 2 times 3 is 6, and then 7 times 3 is 21. Remember, I said b stays the same, doesn't it? It's not being times by anything. So add 5 and then minus 2. Okay? So 6 add 5. Okay, right. I'm not going to use a calculator for that one. I'm confident. And then 21 add minus 2 gives me 19. 11 and then 19. 2 marks. 1 mark for 11. A second mark for 19. That's how the marks are distributed, okay? So ensure you're just getting those finer details correct. And that's an extra 2 marks at the end of a paper you can add to your score, which could be the difference. So always remember, what you're doing now could be the difference. So well done if you're here. Okay, this is a juicy one. So you've got F is 4, 5, G is 5 minus 2, and then 3F, 2G. So let me do my working out here, actually. So we've got 4, 5. That needs to be times by 3. So times by 3, top and bottom. So that's going to be 12 and 15. Okay. The next one was 5. Well, let me do it up here. The next one was 5 minus 2. And then we're timesing that by the number 2, aren't we? So times by 2. Top times by 2. Whoops. Bottom. That's going to give me 10 and then minus 4. So that's my new value here. So 12, 15. Then I've got to take away, looking at the symbol there, take away 10 minus 4 equals. So let's get the vector in. So 12 take away 10 is 2. And then 15 minus 4 will give me 19. So 2 and then 19. Okay? 2 marks again. Now, unfortunately, I'd like these to be worth a few more marks, like maybe 3 marks, but hey, 2 marks, I'll take it. Now, the last bit was slightly different. We've not done one like this in my examples, but we're adding A plus B plus C. Okay, we're adding all of them together. So A is 6 and then minus 10, minus 1 and then 2, and then minus 4 and then 7. And the glorious thing about a calculator is you can do multiple additions at once. So you could do 6, add minus 1, add minus 4 equals 1. So the top number is going to be 1. And then the bottom number, well, that's going to be minus 10, add 2, add 7 equals minus 1. So 1 minus 1. All I'm kind of doing there, and I don't want to simplify this down to the point where you guys are like, Sam, it's not actually that easy. It's still quite difficult, but I'm just understanding what I need to do with the vectors, whether I need to times them up or scale them down or whatever it may be. And then I'm just processing it across. I'm looking at the top numbers, I'm getting a value. I'm looking at the bottom numbers and I'm getting a value. And I'm using the calculator to do all my dirty work. I'm doing the processing, I'm setting it up, where the calculator can do the dirty work for me and get me my values. Okay? So just a quick recap on what we've done today. Let me go straight back to the start. Looked at lines of symmetry and rotational symmetry. We've also looked at the quadrilaterals, which have here. And then we also looked at doing some circle terminology, exploring the differences, and then also looking at vectors. So a bit of everything today. One of the questions I just want to look back on, because I've done a little bit of research, was this one here. Write down a difference between a diameter and any other chord. Well, a diameter, I think, I'm not sure who it was, I think it might have been Josh who might have said, a diameter is always the longest chord because it goes through the center. So all other chords are slightly smaller. But yeah, the difference between a diameter and a chord, just to make your life easier, is that the diameter goes through the center and other chords do not go through the center of a circle. Okay, now draw a little diagram to show you. There's the center. There's the diameter going through, and then a chord could be this, for example, goes from one edge to the other. It doesn't touch the center, doesn't pass by it. Okay, guys, phenomenal effort. An hour slot. We've done an hour and 12 minutes ish. You guys have been phenomenal today. I appreciate it. Hopefully see most of you again next week, and we'll look at other things that are coming up on the paper that we may not get a chance to do in class. So I value you guys for being here. I appreciate your efforts, and I'll see some of you guys soon. If not, I'll catch you online next week. Okay, all the best, guys. Take care and enjoy the rest of your day.